Before we get started, first video posted, it's been great. I mean, we were expecting how many views? What do you think?
5, 10?
5, 10 views, and we were going to be pretty excited about that.
Like all you and me.
Yeah, and it's kind of popped off. For real, we appreciate it, and it's going to be a fun ride. We're excited. We're going to do our best and see how it goes. Yeah.
Oh no.
Oh no. All right, so last time we brainstormed, it was pretty epic.
Yeah.
Now we need to establish some criteria and constraints.
Constraints.
Yep. Those sound like the same thing to me. What's the difference?
Oh, I don't know, like 6 letters. Criteria, things you want to get done. Constraints, things that are stopping you.
So basically, criteria and constraints, what we're doing is we're outlining what is required for us to consider our solution a success. Criteria, bam, we're gonna put them like up here. Constraints, we're gonna put them up there. And we're gonna start just naming off some stuff we can think of. Let's go ahead and knock out the criteria. A lot of these they're ranges. Some of them are based off of some kind of information that we have. And some of them, we're kind of just eyeballing. We're just kind of throwing something out there. And this is where you down in the comments are gonna help us.
I forget they're standing over there half the time.
Yeah, they're just right there. What are you doing? So for example, one of our criteria is launch velocity. How fast does our machine need to be able to throw these discs? And so the bottom is like, say 0, but boom, just drops it out. But let's say the top that it needs to be able to throw it is...
What is the fastest thrown disc?
The last I checked, there was a video of Simon Lizotte throwing 89.5 miles an hour.
So 90?
So 90. There may be someone faster, and that's kind of an old video, but I mean, there's not a whole lot of people throwing that fast.
But if you can throw faster, let me see.
We could set a criteria of 0 to 90 miles an hour.
Okay.
What's something else?
Every angle that needs to be thrown.
All right, so let's do the hyzer and hyzer angle. What angles does it need to be able to throw in order to be successful? My guess is for a righty, 45-degree hyzer-ish and 45-degree anhyzer. I know if you're throwing a roller, you can get higher, and like a grenade, you can get lower, but I think if we go 45 to 45, we're gonna be able to test every disc at what the majority of realistic throws, but I don't know.
I mean, you just need to do your basic throw anyways. That ain't gonna be anything fancy if we're trying to get consistency.
Right. But I mean, I guess down in the comments, let us know. Do you think we need to go higher than 45? Need higher than negative 45? Like, I don't know.
Do you throw at a 90-degree angle? If you do, let me see. 90 degree at 90 miles an hour?
Just Gannon Burr roller, just bang. Right now, we're gonna say our criteria is that it has to be able to throw positive 45 to negative 45. What about nose angle? Negative 5 degrees? Negative.
I don't know. Holding it now I'm like, nah, I might need to be a little bit more than
negative
that.
10 degrees?
Yeah, because
up to, I mean, if you're throwing it that nose up.
I guess maybe 10 to 10.
10 to 10?
Yeah.
Maybe a little higher, maybe.
This is very scientifical here.
Okay, so let's say it needs to go negative 10, which is pretty nose down, to positive 20. I don't know. Let us know in the comments. Let us know. Do you think we need to go higher nose up or nose down? But I'm thinking negative 10 degrees to positive 20 degrees for nose angle.
Okay.
What else we got?
Launch angle.
Launch angle. So we're talking like launching it like up. You don't really need to go too far. Wait.
I mean, zero. Start at 0.
Maybe.
Unless you just want to launch into the ground.
Maybe a little down, because if you throw nose up down, you could throw a.
Okay.
You could throw an air bounce. So maybe a little down.
If we get the machine to do something like that, that'd be impressive.
That'd be cool. It's just air bounce. That'd be sick. So a little down.
So you want to do like negative 5?
Negative 5 down to.
That's 90.
Yeah, this is 90. 45.
I mean, if you want to say 45, I think that's
45's up there.
It's.
But I mean,
I might hurt myself if I throw like that.
I mean, if you launch it, okay. So we'll go -5 to 45 degrees on launch angle.
Well, those are the ones we'll lose.
It could be higher. It could be, yeah. The comments may be like 45. You need to go like 80. I don't know. All right, so -5 to 45. So what we got now?
RPM.
RPMs. Okay, so need to be able to spin the disc clockwise and counterclockwise. This one, I'm basing it loosely off of some like tech disc information that I saw where people were throwing 0 to, I'm gonna guess 2,000 RPMs, because I think I saw some of the higher end throws were like 1,500 RPMs, and 2,000 would be more than enough to cover. Right now I'm thinking 2,000 RPMs is probably more than a human can do, but I don't know, we'll see.
Watch me.
Any other criteria you can think of?
It just needs to make sure we need to be able to throw the putter driver in a mid.
Okay.
They are gonna be a little different.
The rim here, yeah. No, yeah, you're right. Yeah, we got to be able to. Okay, list of criteria here. It's got to be able to throw a putter, a mid, and a distance driver. It's got to be able to control launch angle, launch speed. It's got to be able to control RPMs of the disc. It's got to be able to control nose angle and hyzer angle. Thinking that's every controllable parameter of how you throw a disc. If there's anything I'm missing, let us know.
That's all I can think of.
Okay, let's get into some constraints. Let's put all the limitations that we have to stay within in order to be successful. What we got here?
Power source.
Ooh, yeah. We have the option to do 220. I think it'd be easier if we stay 110 and probably 15 amps.
Thinking about it too, I don't think you would need a 220.
Probably not.
Anyways.
I think you're right.
But it's there if we need it.
Ideally, that constraint will be 110 less than 15 amps. So roughly, what, 1,500 watts, less than that?
Yeah.
All right, let's stick with that. 110, right. 15 amps. What else we got?
Well, we broke, so we're gonna think about that.
That is the universal constraint, money. I guess maybe time's universal constraint, money's second.
Well, time is money.
Time is money. There you are.
Luckily, we got a majority of the stuff thing already.
We have a lot of the supplies already.
I'm not saying I'm a pack rat. But...
We have some motors. We have a lot of frame parts. We're going to need to buy some bearings and some other stuff. I don't know. We have a lot of stuff already, but I hate to do it, but I can sell one of my motorcycles.
Cool. So it's down to we either take the motorcycle apart and use it, or we sell it.
And buy new parts, yep. We'll say the prototype needs to stay under $2,000.
Fair.
Don't tell our wives. Don't tell our wives. All right, we'll try to keep it under $2,000. And if it gets more expensive than that, you may never hear from us again. Other constraints, what we got here?
Size.
Size matters.
We live in Texas.
Yeah, everything's bigger in Texas, but our cars are only so big. And if we want to transport it, it needs to be able to fit in our cars. Luckily, we have SUVs, and I do have access to a truck.
I mean, just for the sake of us, our backs.
Yeah, so another constraint is we have to be able to move it with 2 people, because we're going to build it in the garage, but we got to take it out to the field in order to shoot it. I mean, we have a net, so we'll be practice shooting in the garage, but once it's like really moving, we got to put that in the field. Can't be too heavy or too hard to move. All right, so another constraint is it's got to be safe. We're going to try to meet OSHA safety standards. No, we're going to meet OSHA safety standards. For sure, definitely.
Yeah.
100%.
I got a reflective
Your reflective vest?
And yeah.
That way if it shoots back at you. So, but we're talking like legit safety guards all the way around, interlocks, e-stops, all the good stuff, you know? Make sure that if it's moving, you can't get in there. And if it fires the wrong direction, it won't hit anybody.
I have insurance.
But that brings us to another constraint is aesthetics.
I have spray paint.
It's got to be sick. It also needs to be easy to video. We need to be able to see what's going on inside. I don't want to build a black box and then it just disc flies out of it. It's going to be, we need to do like clear plexiglass all around it so that you can really film it well, see what the disc is doing in there, and then just from a video production standpoint, we can watch it happen.
Okay.
So that's a unique constraint, which you wouldn't necessarily need if you weren't, filming it. So in general, other constraints we have are reliability and maintenance. From a maintenance standpoint, we have to be able to replace parts.
We have to be able to get to the parts. There's nothing more annoying than having to get one bolt, but you have to take apart 8 other bolts before you get to that bolt.
I feel that when we design this, we need to be able to actually replace items and get to them fairly easy. So any of the frame parts that need to be removed often, we're going to pin them instead of bolting them down. The motor and everything, we need to be able to get to it fairly easy. And any part that's going to be a wear part, we need to be able to replace them fairly easy. Nothing like welded on. Major frames can be welded, but anything that has to be replaced.
Don't weld the bearing. Okay.
So that's part of the constraints. It's got to be decently water resistant.
Oh, yeah.
So we're not going to dunk it, but it may get rained on. So
Right.
all of our electrical components have to be IP rated up to something. Not sure what that number is, 66, 68, I don't know. All right, I think that's a good list of criteria and constraints, and the comments will...
Dog just appeared out of nowhere.
It's crazy. Yeah, that was a good list of criteria and constraints, and the comments will keep us honest.
I have nothing to lie about.
If there's anything we're missing, drop it down there. And next episode, what are we doing?
Explaining our approach,
Yeah,
considering alternative approaches.
yeah, we will be considering all of our solutions, our potential solutions, and pretty exciting.
I think we have an idea that's good enough.
We're gonna select one. Next episode, we'll be selecting the approach we're doing, right? This dog used to hate. So until next time,
Bye.
bye.
Fuck it, I'm not putting this in. This has a spider in it.
Ooh. What else we got?
Well, bye.